From grip to durability, much effort goes into crafting car tires that are up to the task. Ever curious about the complex engineering that puts rubber to the road? Crafted for safety and engineered for longevity, tires are often overlooked masterpieces. Stick around as we dig into the nitty-gritty of these daily necessities. Before we delve in, let's take a quick 30-second trip to explore how car tires have evolved over the years. History. The history of car tires has seen a remarkable evolution, beginning with simple leather bands and iron hoops wrapped around wooden wheels. The game changer was the invention of vulcanized rubber in the 19th century, significantly enhancing durability and grip. The 20th century introduced radial construction, which added further stability and longevity. Nowadays, we have tires specialized for different weather conditions, terrains, and even fuel efficiency. Advances in smart tire technology are already in the pipeline, aiming to revolutionize safety with real-time monitoring features. Materials. Moving on from our brief history lesson, let's dig into the building blocks of car tires, the raw materials. At the core, natural rubber sourced from rubber trees is an essential ingredient, giving the tire its fundamental elasticity and resilience. Synthetic rubbers, derived from petroleum-based chemicals, complement the natural rubber by offering properties like resistance to oil, temperature variations, and abrasion. Carbon black is another crucial component. It's a fine black powder made through the incomplete combustion of heavy petroleum products. When mixed with rubber, it significantly enhances the tire's durability and provides greater road grip. Silica, another reinforcing filler, is used alongside or in place of carbon black to reduce rolling resistance, thereby improving fuel efficiency. Various oils, such as aromatic oil or naphthenic oil, are also integrated into the mix to soften the rubber compound and make it easier to process. Specialized chemicals like anti-degradants and accelerators are added to protect the rubber from environmental degradation and to speed up the vulcanization process, respectively. Design considerations. The tire's design is not just about its circular shape or the tread pattern. It's a complex blueprint that has evolved to meet specific performance requirements. The first aspect designers focus on is tread pattern, which must be meticulously engineered to offer optimal grip, especially in wet or icy conditions. Different types of tires, like all-season summer and winter tires, have varying tread patterns to perform well under their designated conditions. The internal structure of the tire, often made from steel and fabric cords, is also a critical design consideration. This internal skeleton provides the necessary rigidity and allows the tire to maintain its shape under different stress conditions like high speed or heavy load. Tire designers also look at factors like sidewall stiffness, which affects handling and ride comfort, and rolling resistance, which impacts fuel efficiency. Special materials may be used in the sidewall to withstand curbs and potholes, ensuring longevity and consistent performance. Moreover, designers have to consider how the tire will dissipate heat. A tire that gets too hot could deteriorate faster, so materials and construction methods are selected to maximize heat dispersion. Fun fact: believe it or not, the best modern tires can last up to an astounding 100,000 miles, all thanks to breakthroughs in rubber technology and innovative design. That's like traveling around the Earth's equator 4 times on a single set of tires. If you enjoyed our explanation so far, hit the subscribe button to stay in the loop for more fascinating stories behind everyday objects. Mixing and melting. This phase begins with the rubber being mixed with various additives in a large mixer to create the compound that will form the tire. Carbon black for increased durability, sulfur for vulcanization, and other additives like oils and resins are mixed at high temperatures. The compound undergoes several mixing cycles to ensure that the materials are thoroughly blended. Once the mixture is ready, it is then heated to a semi-fluid state. This melting process makes the rubber compound malleable, enabling it to be shaped into the tire's intricate features, such as the tread and sidewalls. It's critical for the melted rubber to have the correct viscosity. If it's too thick or too thin, the tire could have structural issues. During this stage, other components like steel belts, fabric cords, and bead wires are also prepared. These elements are coated with rubber and are ready to be integrated into the tire structure during the molding process. Calendaring. In the calendaring phase, the heated, semi-fluid rubber compound is passed through a series of rollers to be transformed into sheets or continuous layers. These sheets are not only made to the precise thickness required for different parts of the tire, but are also textured to enhance their performance characteristics. For tires with multiple layers, or those that require reinforced materials like steel or fabric, the calendaring process becomes even more intricate. Layers of fabric or steel belts are often coated with rubber during this phase. This ensures that these reinforcing elements are properly integrated into the tire, adding to its strength and durability. It's during calendaring that specialized textures, like those found on the tire's tread, are imprinted. The rubber sheets may pass through textured rollers that imprint these patterns, which are critical for grip and water dispersion on the road. Calendaring is an exact science, demanding rigorous quality checks. The thickness, texture, and evenness of the rubber sheets are closely monitored to ensure they meet strict tolerances. Building the tire. The calendared sheets and other preformed components converge at this stage to form a recognizable tire shape. This is often done on a tire building machine, which serves as a kind of scaffold for the tire's structure. The process starts with the inner liner, the airtight layer that retains the tire's inflation. The liner is placed onto the tire building machine, setting the stage for the subsequent layers. Next comes the body ply, usually made from polyester, which adds structural integrity to the tire. The sidewalls are then added, followed by beads, which are steel wires coated in rubber that help the tire to grip the rim. One of the most crucial elements added at this stage is the belt package, usually composed of steel and sometimes Kevlar. These belts are positioned between the tread and the plies, and they play a significant role in determining the tire's performance characteristics, such as durability, traction, and handling. Lastly, the tread is applied. This is the part of the tire that comes in direct contact with the road, and its design is often specialized for various road conditions, driving styles, or vehicle types. During this building phase, adhesives and heat are often applied to ensure the various components are firmly bonded together. The tire then goes through an initial inspection for quality control. Imperfections, if any, are either corrected or, if severe, the tire is rejected and recycled. And another car tire fact: approximately 80% of an old tire can be recycled and repurposed for uses like these. Talk about giving rubber a second round on the road: curing and molding. After the assembly stage, the tire is still far from road ready. That's where the curing and molding process comes into play, transforming a green, unvulcanized tire into a durable, high-performance piece of engineering. First, the built tire is placed into a curing mold, which is essentially a large, heavy-duty metal chamber designed to withstand high temperatures and pressures. This mold also features the intricate tread pattern and tire markings that will be imprinted onto the tire's surface. The curing process starts by applying heat and pressure within the mold. The heat activates the chemical accelerators within the rubber compound, kicking off the vulcanization process. Vulcanization fundamentally changes the rubber, making it more elastic, heat-resistant, and durable. This stage typically lasts from 10 to 20 minutes, but it can vary depending on the specific type of tire being produced. During this process, the rubber flows to fill the mold's cavities, taking on the shape and tread pattern designed into the mold. It's this stage that gives the tire its final form, including all the minute details like sipes, treads, and sidewall markings. Once the curing is complete, the tire is removed from the mold and moves on to the final quality inspections. This involves both visual and machine inspections to make sure the tire meets all safety and quality standards. So there you have it. The tire has journeyed from a humble mix of raw materials to a sophisticated product, engineered for safety and ready to grip the road. After passing rigorous quality inspections, the tires are boxed up and prepared for distribution, one step closer to ensuring safe and efficient travel for drivers around the world.